You can monitor Exadata system performance by using various tools and information sources. The following topics introduce and compare the main Exadata performance monitoring tools and information sources. Automatic Workload Repository, AWR. Database Statistics and Wait Events. Exadata Metrics. Exadata Alerts. Real-Time Insight. ExaWatcher. AWR collects information from various database dynamic performance views at regular intervals. Each data collection is an AWR snapshot. An AWR report shows statistics captured between two AWR snapshots. AWR collects and reports a wealth of statistical data related to Oracle database, including database statistics and wait events from $systat, $system_event, $segment_statistics, $SQL. The Exadata Server Configuration section of the AWR report shows configuration information from all of the associated storage servers, including model information, software versions, and storage information relating to cell disks, grid disks, ASM disk groups, and the IORM objective. By examining this information, you can easily see any configuration differences across the storage servers that could potentially affect the behavior or performance of the system. The Exadata Server Health Report section of the AWR report shows information about offline disks and open storage server alerts. When a disk is offline, then the total I/O bandwidth is reduced, which may affect I/O performance. Alerts represent events of importance on a storage server that could affect its functionality and performance. Open alerts are alerts that have not been marked as examined by an administrator. Exadata Statistics. AWR includes statistics from various Exadata storage server components, such as Smart I/O, Smart Flash Cache, Smart Flash Log, PMEM Cache, PMEM Log, and I/O Resource Manager. It includes I/O statistics from both the operating system and the cell server software, and performs simple outlier analysis on these I/O statistics. Because Exadata typically distributes I/O operations evenly across all cells and all disks, outliers may indicate a potential problem and warrant further investigation. If any cell or disk is behaving differently or performing more work, this could potentially cause slower performance for the whole system. The Exadata Statistics section of the AWR report includes the following subsections. Performance Summary. Exadata Resource Statistics. Exadata Smart Statistics. Smart I/O. Write Offload. Flash Log. Flash Cache. Memory Cache. PMEM Cache. Exadata I/O Reasons. Top I/O Reasons by Requests. Top I/O Reasons by MB. Internal I/O Reasons. Exadata Top Database Consumers. Top Databases by Requests. Top Databases by Requests Details. Top Databases by Throughput. Top Databases by Requests per Cell. Top Databases by Requests per Cell Details. Top Databases by Throughput per Cell. Exadata I/O Latency Capping. Cancelled I/Os Client. Cancelled I/Os Cells. Exadata Flash Where. Exadata performance can be measured through cell offloading, smart scan, storage indexes, hybrid columnar compression, DBRM/IORM, smart flash cache. Cell offloading is the generic term to describe what is now done at the storage tier that would have been done at the DB tier. Smart scans are the access mechanism used to offload the task's data file initization through ASM speeds up initialization. RMAN offload, when block change tracking is used with RMAN and Exadata, the cell does the incremental backups at the granularity of a group of blocks as is done without Exadata. With Smart Scan there are two main wait events. Cell Smart Table Scan. Cell Smart Index Scan. The flow of data from SmartScan can't be buffered in SGA buffer pool. Storage index is an in-memory structure that holds some information about the data inside specified regions of physical storage. More importantly, it knows what is not located in that region. Think of it as a pre-filter. Storage indexes word in the negatively, it finds where it doesn't exist and therefore eliminates cells needed to be looked at. To use them, the queries must use smart scans, which means not all queries will benefit. Typically they are utilized for queries using predicates, full table scan or fast full scan of indexes. Hybrid columnar compression utilizes a combination of both row and columnar methods for storing data. A logical construct called the compression unit is used to store a set of HCC rows. When data is loaded, column values for a set of rows are grouped together and compressed. After the column data for a set of rows has been compressed, it is stored in a compression unit. To maximize loading, use below DW options. However, you can also regular DML. Insert statements with the append hint. Parallel DML. Direct path SQL * LDR. CTAS. Types. Query low. Query high. Archive low. DBRM, Database Resource Monitor. This is the resource manager you are familiar with. Without all sessions are given equal priority. The main reason is for use with consolidation. DBRM is actively throttling CPU consumption. Check DBRM metrics $v$RSRC_consumer_group, also $v_$rigmetric and $v_$rigmetric history for monitoring effect of DBRM resource allocations have on sessions. Instance caging, provisions CPU at DB instance level. IORM IO resource monitor. Added with V2 and beyond. Can prioritize IO across DBS. For first time can virtually guarantee IO service levels within and among DBS. CPU quantum, wait event. ResMGR, CPU quantum. Is the unit of CPU time that the DBRM uses for allocating CPU to consumer groups. Occurs when IORM. Interdatabase IORM manages priority among multiple DBS by DB name. IORM categories, this is a new attribute. Still by name. XOLTP_category batch_category. Intradatabase IORM on Exadata. When a DBRM plan is activated, the DB transmits a desk of this plan to all cells in the storage grid. So in a way this is a bit of the default. IORM manages at the storage cell. IORM distinguishes between small and large IO request, 128K in size or 128K. For each cell, disk cellserv maintains an IORM queue for each consumer group and each background process. For each DB accessing the cell. Selply alter IORM plan objective equals low_latency. Selply list IORM plan attributes object low_latency. Exadata flash cache. This feature is what allowed V2 to be good for OLTP databases. 5 terabytes on a full rack. 366G usable flash storage per storage cell. Can be used in 2 ways, or both. Configured as cache, recommended. Carved out as solid-state disks for ASM. Write through cache. Writes bypass the cache and go directly to disk. However, can copy data into cache if likely to be used again. Follow by querying $systat and related $views. Cell flash cache read hits. Cell_flash_cache equals keep. None, default, keep. Alter table oltp.busy_table, cell_flash_cache equals keep. Selply cell_flash_cache equals keep. Create flash cache all size equals 300G. List flash cache detail. List cell disk attributes name, disk type, size where name like FD**. List matricurant where object type equals flashcake. List flashcache content, shows objects in cache. Follow by querying $systat and related. $views. Can be overestimated if all in keep state. Cell flash cache read hits. What to look for when tuning. SQL statement response time monitoring. DB layer utilization and efficiency. Storage cell layer utilization and efficiency. Advanced metrics and monitoring for Exadata. We'll be looking at SQL statements v $views, Celcli, OS Watcher, Cell Smart Table Scan Event C offloading, Cell Smart Index Scan How fast full index scans that are offloaded.